Welcome back. In Module 2, we'll be focusing on modernizing legacy infrastructure and applications. So let's jump in and take a look at what you'll learn in this component. So we'll talk about some of the new Windows Server 2012 R2 features that are important for you to plan to include with your customer base. We'll talk about some of the upgrade scenarios as you move to Windows Server 2012 R2. We'll cover the Windows Server 2003 end of support. We already mentioned this briefly during the introduction piece, but it's time to start drilling into that into a bit more detail. And then we'll start taking a look at how we can start migrating roles and shares, for example, across to Windows Server 2012 R2 with the Windows Server migration tools. We'll talk about migrating server applications, and then we'll also talk about migrating virtual machines and physical machines to the cloud with the Microsoft Migration Accelerator preview. So this is a fairly recent release, so hopefully it's something that you'll learn about and be able to take advantage of. So now let's take a look at the new and improved Windows Server 2012 R2 features. So obviously this is a very, very small subset of the capabilities that are available in Windows Server 2012 and 2012 R2, but we'll talk about some of these in a bit more detail as we go through, but let's run through them quickly now. So first of all, with Windows Server 2012, the first release of Server 2012 was the first time Microsoft officially supported inbox NIC teaming in Windows. So even though there's been solutions from all of the major hardware vendors for a while, it's not really been something that Microsoft has officially supported, even though the capabilities were there. So now this is something that Microsoft Support will actually handle for you. So if you are having issues with a multi-NIC configuration with NIC teaming enabled, they will be able to support you on that. Now, next up, we've got SMB3 multi-channel. So this is where we can just keep adding more network adapters and keep scaling out the amount of bandwidth that's available to the server. So in this case, it's working independently of NIC teaming. So we don't need to team these or aggregate them together. This is really just, I know sometimes it sounds like an exaggeration, but it really is just plug and play in terms of adding in new NICs. You might drop in a quad port or a dual port adapter into an existing system, and all of a sudden you've got multiples of the bandwidth available to that server. We'll come back and talk about SMB Direct in a little bit more detail. We've already spoken about SMB Direct or RDMA previously, but it's worth talking about it now from this perspective, just in case it is something that is appropriate for your customers. We'll spend a little bit of time on failover clustering. An important thing to note with failover clustering, though, is that it is just a standard feature that's included in the data center and the standard version of Windows Server. Whereas with Windows Server 2008 R2 and earlier, you needed to be looking at the enterprise or the data center version of Windows Server to get these kind of failover clustering capabilities, but now they're just a standard part of the Windows Server standard upwards products. So there's an all-new check disk. So obviously, the check disk requirement has been, pretty much driven by the ever-increasing amount of storage that's available. So running check disk on an old operating system with a 20 megabyte hard drive wouldn't have taken that long. Running it with a 200 gig hard drive, that might take a little while. Running it with maybe 20 terabytes of attached storage, that really might take a long time to run using an old version of check disk. So obviously there have been performance enhancements to make sure that it can scale with the changes that have been presented to Windows in the storage by the storage vendors. Now there's also a new file system called REFS, or the Resilient File System, which we'll spend just a short amount of time on as well. Now, we've also got improvements to Active Directory domain admin services, so simplified administration, fine-grained password policy. We'll talk about the recycle bin. We'll also talk about PowerShell, and even though we will be mentioning PowerShell a few times during the course of this session, it's not essential that you know PowerShell, but I strongly recommend that you at least have a couple of commonly used PowerShell commandlets up your sleeve so that you can pull them out when you need to get certain things done, especially repetitive tasks. So with that, let's jump in and take a look at NIC teaming. So as I mentioned, NIC teaming is now inbox with Windows Server. You've got support for up to 32 network adapters. You can have lots of virtual interfaces. You can have multiple teaming modes, so different ways of failing over. So depending on what kind of networking infrastructure you've got, you might have a switch that supports certain types of failover or teaming capabilities, so you can either work alongside your NIC, or you could even do switch independent NIC teaming as well. So there's no requirement for your switching equipment to be aware of what it is you're actually doing here. Now you can manage multiple teams on the same server, and as I mentioned, you can manage this through PowerShell if you really want, or you can do it through the user interface. Now, just to give a quick run through of the different modes in a tiny bit more detail, you've got switch independent mode, which means that the NIC team members can connect to different switches because there's no real dependency on the switch to know what's going on. Whereas when we take a look at some of the switch independent modes, the switch is participating alongside the NICs for purposes of teaming. So this might be something where you've previously worked with a vendor who does end-to-end teaming services that require on the capabilities of the network adapter and the switch that they provide. So you may find that in some cases you may want to go down the switch independent mode, but if you've got switching infrastructure from a single vendor that you know works quite well in a dependent mode, then you might as well keep using that, because that vendor is going to know how to make the most of it. As we take a look at SMB3 multi-channel, to me this is really one of the big exciting changes that occurred in the SMB file sharing protocol with Windows Server 2012, and it just keeps getting better. But what we can do here is we can start aggregating network adapters of the same speed to present a larger overall pipe to SMB traffic. So if we take a look at the examples that we've got here, on the left we've got a single 10 gig Ethernet adapter. So for a lot of people, they'd look at that and go, oh yeah, that's fast. But it may be fast, but there's no inherent failover capabilities in that. If we jump across to the next one, so multiple gigabit Ethernet in load balancing and failover capabilities, in this case, they may both be distributing the load, they may be increasing throughput, but the important part here is that if one of the NICs becomes unavailable, or one of the network parts becomes unavailable, the other NIC can keep on working. Now, we can also just do multiple gigabit NICs. So if we want to add in this case, we've got 2 1 gigabit NICs, we may have 4, we may have 8. And if you think of it as something that does scale very, very well as you add more NICs to the system. But what you do have to remember though is the more potential traffic you've got between servers and storage, the more of a load it can place on the storage subsystems. So making sure that things are fairly evenly matched, so that you don't over-invest in one area to find that it's being held back by the other, for example. Now, for those situations where that 10 gig speed is attractive, but you do want those failover capabilities as well, you can do SMB3 multi-channel with 10 gig Ethernet as well. So this means that you're really getting the best of everything. You're getting high performance from a single connection for things that don't take advantage of SMB, but then anything that runs over the SMB file sharing protocol, such as Hyper-V, can really leverage those two 10 gig connections effectively as a dual, as a 20 gig connection. And there's nothing you need to do to actually configure that in order for Hyper-V or the file and print service or the file services, for example, to be able to take advantage of that. So this starts introducing some great capabilities. So as I mentioned, it gives you failover capabilities. So if one of the NICs can't connect for some reason, it could be a cable is pulled out, it could be the chips die on the NIC, it could be it gets unplugged from the switch, for example. If there's an alternate path, it will keep working. So the throughput is effectively an aggregate of all of the different connections that are the same speed. So in this case, if we take a look at that multiple 1 gig Ethernet adapters, if we added a 10 gig NIC into that, it wouldn't really be able to participate as something where you could say you've got 12 gig combined of SMB throughput. Instead, you could say, well, we've got 10 gig plus 2 gig. And what also happens here is, as you can imagine, starting to push all this additional network traffic has got the ability to start stressing other parts of your hardware quite hard. So in this case, it's something that can take advantage of that receive side scaling network adapters that I mentioned earlier, where we can actually offload any kind of CPU requirement to the NICs if the NICs can support these capabilities, so that the CPUs can keep doing what it is you want the CPUs to be processing, while the NICs are effectively taking over the workload here. And finally, one of the things that I've already mentioned a few times is that it's automatic. You plug it in, it works. If there's a way it can get from point A to point B, it will figure out how to do that. And it's one of the things that I've found most useful with it. Now, for the storage networking, what we can start doing here is referring back to that RDMA. With storage networking, we've got the ability to really start taking advantage of very, very high-speed network connections between servers with these RDMA or SMB direct network adapters. And what these allow us to do is to really start bypassing the CPU so that we can do memory-to-memory transfers of content from one server to another. So this is something where we're generally talking about adapters, in the 50 gigabit per second range. So we're talking about very, very high performance networking adapters. So this is not necessarily something that's going to be of use to a lot of smaller customers, but for larger customers, it may be something when they're looking at some of the solutions, when you're talking to your hardware vendors, you may find that if they're offering some of these options, you'll probably figure out there's a customer or two that you may actually be able to take advantage of this with. So it provides very, very low latency connectivity. Some of the brands that you'll see spoken about with these kind of capabilities are InfiniBand and iWarp, and it provides the traditional advantages of your normal file shares, which is it's very easy to provision, migrate, configure. It's still the same kind of permissions and setup, etc. underneath, because it's still all Windows Server that's running underneath this. So there's no application changes required. Admins don't really need to learn anything special in order to get it up and running the way that they normally would get just your typical file and print server up and running. And it's something that, as it says here, it can be used with SMB multi-channel for load balancing and failover capabilities as well. Now, as we move on to the clustering capabilities, some of the important things with this is that a lot more smaller customers are investing in clusters, whereas years ago we'd think of clusters as very, very expensive. But now there are quite a few more of the cluster in a box type solutions where you may have shared storage, multiple Hyper-V hosts that will go through and start providing failover capabilities for things like file and print services, SQL Server, as well as your other network services. And this failover cluster support is just baked into the Windows Server Standard Edition and Windows Server Data Center so that you can pretty much just choose the version of Windows that's right for the customer and still get these failover capabilities. So for larger customers that you may have, important things here are that it is much more scalable than previous versions. In one of the earlier slides, earlier in the sessions, we were talking about how you could scale up to 64 nodes per cluster. So while that's not something that really is going to probably positively impact too many SMB customers, for your peace of mind, it means that you do have room to grow with a customer that may have aggressive expansion plans over time. So you can just do things like use Server Manager to create server groups to manage sets of machines, such as nodes in a cluster, and you can assign those to a server group, and then you can start managing them all much more simply rather than trying to manage them as isolated servers. Now, I've already spent a little bit of time on check disk, but let's just sort of drill into it in a little bit more detail. But with NTFS volumes having grown dramatically in size over the years, if someone's running an older version of check disk with Windows Server, they're probably finding that whenever check disk needs to be run, they've got to plan for quite a while for it to actually occur. So now check disk is something that is much more efficient. And this has obviously been a very, very high priority. So in this case, there are situations where it will go through and it'll pick up and avoid some of the mistakes that they made with 2003 and 2008 check disk. So it won't go through and do things such as scan the entire volume if there's a single piece of corruption. It won't need you to sort of take the machine offline for these kind of transactions to occur. So let's jump in and take a look at some of the more specific issues or details of what has changed. So you've got improved self-healing, so it will go through and do instantaneous self-healing without requiring check disk to run online. So that's obviously a really, really big improvement for people who may have had aging hardware running Windows Server 2003, and they may have gotten to the point where they just hated seeing the check disk screen coming up because they knew they had to plan some downtime for that server. And some of the things that were found when they were doing the analysis of people who were running check disk was that there was more time spent scanning and analyzing the drive rather than the time it actually took to run check disk. So now with Server 2012 and 2012 R2, the analysis phase of checkdisk can actually now run online as a background task. So then when checkdisk really does have to do something, if you do need to take the server offline, it's something where it can actually perform it much faster because it's already pre-processed a lot of what it needs to do. And then finally with the correction, once that scan is complete, it will go through and it will use the event, it will use the standard server management console to present this information to you. So it gives you a lot more information and makes sure that it does bubble up so it's easy for you to identify what's happened. So now we're talking about upgrading from old versions of Windows Server. A lot of the conversation may be focused on people who are running Windows Server 2003, but it doesn't mean that people who are running Windows Server 2008 versions are immune from wanting to upgrade as well. So they may not have the same degree of urgency, but it may be something where they're looking at consolidating on a common platform across all servers. They may not want to run a mix of old and new servers on the physical hardware. So what are some of the steps you can take to do these migrations? So first of all, there's no real way to upgrade Windows Server 2003 directly to Windows Server 2012 R2. And I really wouldn't recommend doing an in-place upgrade of Server 2003 64-bit to Server 2008 64-bit to Server 2012 64-bit. I think most of us are at the point where we know that doing in-place upgrades, while it may work, it's not really going to set the basis for that most the rock solid reliable OS we want to run all of the infrastructure for the company. So in this case, I generally push people towards a clean install and migrate the settings that you need rather than trying to keep everything running as is. Now, you can do things around switching between server core and full GUI mode, for example, but that's something that we can do after the actual installation. So we'll come back and we'll spend a little bit more time on that later in this deck. So now let's take a look at the upgrade matrix. So if we're running this, what can we move to? So I won't go through all of these, but we'll just sort of focus on some of the top level ones. So what you need to look at first of all is that anyone running data center needs to or an old version of data center, they need to upgrade to a new version of data center. Someone running an old version of enterprise can move to standard or Windows Server because, as I mentioned, the enterprise capabilities from the network load balancing and failover clustering are now also included as part of the Windows Server Standard product. And Windows Server Standard, old editions of that can be moved up to standard or data center in the 2012 R2 world. Now, some of the more specialized ones, such as web server, that needs to be upgraded to standard. And as we go through, Hyper-V 2012 can be upgraded to Hyper-V 2012 R2. Other things in here that probably aren't as critical now because we've been a few steps removed from it for a while is just like desktop operating systems, you can't do 32-bit to 64-bit in-place operating system upgrades. So just be wary of that. So some of the changes we've seen with recent versions of Windows Server is that we can now do core installation, which is a minimal installation of Windows Server, which uses less disk space, has a smaller attack surface, and has lighter servicing requirements. But for a single server environment or for only a couple of servers, if you're more familiar with the GUI tools and PowerShell isn't something that you're overly comfortable with, then you may just be comfortable sticking with the full server installation. And there's nothing wrong with that, provided you know the pros and cons of both. But one of the changes that's now occurred with Windows Server 2012 R2 is that instead of going just between server core and the full server, you've also now got an interim step where you can actually have something that sits in between that allows you to run the management tools on top of Windows Server, but doesn't include all of the other stuff that Windows Server potentially can install for you. So let's jump in and take a look at some of these differences. So first of all, with Server 2008 and R2 server core installation, it was really a matter of you had effectively something that gave you a command shell when you logged in, or you had full server. You didn't really have anything in between. So for some people, that instant push back to a command shell was probably a little bit too much of a push in the direction that they weren't quite ready for. So with Server 2012 and R2, what we've now got is the ability to have the server core with the GUI shell and the GUI management components separated out, and then we can add them in as we need them. So what this means is that we can go through and take advantage of this modularity. So the server GUI and the server management tools are now features that you can add and you can remove using Server Manager. You can use PowerShell, or if you like working at the command line and you're used to the DISM tool, you can also use DISM. So one of the differences between installing the core and installing the full GUI and then removing the GUI shell is that when you perform the core installation, you do not get all of the binaries installed that would normally get installed. So then if you do want to get an understanding of what the difference here is here, the footprint, if you just do a core installation, the disk footprint drops from 20 gig to 4 gig. So we're talking about a pretty significant amount of space that is reclaimed here. Now, in today's world where we've got probably more storage than we know what to do with, we may be thinking it's not that big a deal. But in a lot of cases where people may have smaller SSDs that they're using to boot the operating system to keep things running nice and quickly, and then the arrays may be based on traditional mechanical drives, this means that server core does give you some great advantages there. So just remember those if you do start adding features back into server core, that it needs to get access to a Windows WIM file in order to get access to the bits and the binaries that it needs to actually expand out that feature set again. Now, with the server core, as I mentioned, it's a minimal server interface. It really is just that command prompt shell that includes PowerShell support and Server Manager support, and a little bit of control panel, but don't expect the full control panel. And then you've got the full GUI, which gives you everything. So they're the two extremes, but let's take a look at more of a feature-by-feature description of these. So if we take a look, things such as the command prompt, PowerShell capabilities, .NET support, these are available across the board, but as we start working our way through here, what you'll see is that things like Server Manager isn't available in Server Core, but it is available in the others. If we jump down a few more, Control Panel isn't really available completely until we've got Server with a GUI installed there. And as we keep working through, I'll let you read through that yourself, and you can also download a copy of the deck to see more details. But if you really want to turn it into something where, a more fully functioning remote desktop server, for example, and you want to have themes and modern apps, etc., and media player installed, you don't just need to install the server GUI, you also need to install the desktop experience feature pack. So that's what you'll see down the bottom, where all of a sudden, server with GUI doesn't give you everything, because not every server, or actually the majority of servers, do not need to have end user experience components installed. Now, to upgrade the server core to a full GUI, we've got different ways of doing this. So we can use DISM. So with server core, remember, we don't have the ability to run Server Manager. So if we take a look, I won't read out the instructions. Instead, this is something you can do in your own time. And we can take a look at some of this inside of the demonstration that comes up next. But we've got the DISM command line option where we can basically work with the online image, add the features we need, and as I mentioned, we do need to be pointing to the location where the WIM file exists so we can bring those features in. Now, the alternate option is that we can use Windows PowerShell. So if you're familiar with PowerShell for other things, the chances are you can pick this up pretty easily and keep working with it. So the beauty of PowerShell is that it doesn't matter what product or technology you learn PowerShell for, your PowerShell skills can then be applied across the board, because you're working with a common syntax of verbs and nouns, and then piping results through and processing them as needed. So you can make PowerShell as complex or as simple as you need. Some people just do things where they cut and paste and they collect the PowerShell scripts that they've used once and then keep reusing them and just pulling them out of a notepad file. So it's really up to you which option you use, but what we'll do now is we'll jump into a demonstration so you can see how easy it is to add the GUI shell into Windows Server Core Edition. So here we are inside of Windows Server Core. The way we can tell it's Windows Server Core is that we don't have any kind of taskbar, we don't have a Windows key to access anything, and all we have is a command prompt. So we have two different ways that we can add the full GUI capabilities and the server management capabilities in here. And the one that I'll show you here is DISM, which you can do with a single command line. And you can see that even though I'm saying it's a single command line, it is quite a long command line. So if we just take a quick look at this, if you're not familiar with the DISM tool, I mentioned it briefly on the previous slide, but it is something that a lot of OEM partners, a lot of people who build corporate images, so people who work on SOEs, for example, may be familiar with. But it allows us to mount either an online or an offline Windows image and make changes such as inject drivers, inject updates, etc., directly into that image, so that we could, for example, have an offline library and go through and do certain types of updates and management without having to bring each of those images online. But in this case, we're working with this machine itself. So what I'm doing is working with the online image, and we're giving it the command to enable features. So the feature name is, or the feature names, is actually three different things that we're doing here. We're adding the server core full server, we're adding the server GUI shell, and we're adding the server GUI management. So this is effectively going to add the full overlay of the different components of the tools into the environment. Now we can also specify the source here. So the source being a WIM file, and this is sitting on the CD that it's currently mounted, or it's actually an ISO, of D sources install.wim4, and we're just telling it to pull it out of image4 inside of that Windows image file. So what's going to affect the timing of this is, first of all, things such as the speed of the machine, the speed of the drives, etc. But also, if it's something where if it doesn't have access to the source files, it may go out to Windows Update, for example, and pull those files down for you. So if you've got a slow connection and you're not pointing it to a specific path, this can actually take a while to go through and perform. But in this case, it won't take too long because we do have the files locally, so it can go through and get all of these features installed very, very quickly for us. Now, if we just do a compare and contrast back to the way that we can do this with PowerShell, in this case we need to, inside of PowerShell, we need to mount that WIM file that we're referencing there, so the D sources install WIM, and then once that's running, then that's where inside of PowerShell we need to use the install Windows feature command to add in those, the server GUI, the management infrastructure type commands, and give it a restart. So you can see here that it's performed quite quickly. So it'll go through, and in a couple of seconds it will prompt me to restart. And we'll just let that run through and go to completion so we can see what happens on the other side. So why would you use DISM versus using PowerShell? Well, the DISM option is great for people who already know how to use DISM. If you're not familiar with using DISM, what I'd suggest is investing in learning the PowerShell methods. It's a couple of extra steps when you do use PowerShell in this case, but it really does make it a lot easier longer term because those PowerShell skills will be applicable to other things you need to do as your PowerShell requirements do grow. So what we can see now is that it's working on features, so it's adding those new features in, and it's going through at a fairly rapid rate. And remember though, we are installing quite a bit into the operating system here, because one of the big benefits of Windows Server Core Edition is that it just doesn't take up anywhere near as much disk footprint. So that's got benefits in terms of how much storage is required, but also things like the attack surface, the amount of patching, etc. that's required over time. So once we get to this point where it restarts, we'll see that once I log in, I'll be back into more of a traditional Windows type interface rather than that pure command shell that may be a little bit scary to some people who aren't familiar with the command shell or with PowerShell at all. So we're nearly there. We'll give it a few more seconds and then we should be able to log in. Okay, so now we're back in, and you can see that we've got the full tools. Server Manager has kicked off as we'd expect it to, and from there I can go through and configure this just like any other Windows server, because now it's effectively that full installation versus the core installation. Jumping back into the presentation, let's take a look now at some of the things you need to think about when it's time to start migrating from older versions of Windows Server up to Windows Server 2012 R2. What's driving a lot of this at the moment is the Windows Server 2003 end of support, which occurs on July 14 in 2015. So this is giving us less than a year to get our customers who are running old versions of Windows Server over to the latest versions of Windows Server. And there's really a four-step process that Microsoft is promoting in a fairly consistent manner, regardless of the size of the customer or to the partner they're talking to make sure that everyone is speaking the same language here. So if we take a look at the four steps, it's very easily broken down into, first of all, discover. So it's a lot easier to migrate things when you know they exist. So if you can do a good job of discovering what the customer has got, obviously the following steps are going to be easier and lead to less surprises. With assessment, this is really all about you sitting down and taking a look at what it is that you've discovered and working with the customer to identify what are the high priority workloads that do need to move from older versions of Windows to newer versions of Windows. Which are the ones that probably aren't as important, or what are some of the ones that you may actually say, look, it's an old product, it's time to let it go. Here are some of the alternatives that are available. As we move on to number 3, which is targeting. This is where things start getting quite different from previous Windows Server migration scenarios where, up until now, for a lot of customers and partners, the option has really been, well, let's take you to the new version of this thing. But in this case, or in this world today, for some customers, this option may be better provided by a cloud solution. So something like Azure with virtual machines or Office 365 or your own hosting services for certain types of workloads. So a great example of this for a lot of customers is, traditionally they may have run Exchange on-premise because they really didn't have any other way to get access to it when they first started using Exchange. Whereas that's one of the easiest workloads for most organizations to move into some kind of cloud environment. And then the final piece is once you've discovered, you've assessed and you've targeted where things are going to go, you actually take them to where they need to go. So this is the migration step. So obviously the more work you put in these initial 3, the easier that migration piece is going to be. And for those of you who are lucky enough to have customers who run fairly similar environments, it means that migrating the second customer, third customer, fourth customer, etc., are going to get a lot easier because you've already sort of discovered what the little bumps are, what the tricks are that you've got to do maybe with some of the older applications to move them forward. Some of it's probably even around the conversations that you'll get better at with some of the customers who really want to hang on to older technologies because they don't really think they've gotten full value out of it yet. Whereas that if they do stick with an old version, running on top of Windows Server 2003, they are going to be in a situation where it's not just that they're going to be unsupported by Microsoft, there's going to be other ramifications for them for running this older software as well. Now, I'm not going to go through all of the different options here because we've got some Microsoft offerings, we've got the Windows Server migration tools and the Microsoft Migration Accelerator, which I will cover, but there's also a whole bunch of different partner offerings here. So depending on what you're moving from and what you're moving to, these different programs are going to be offering you different capabilities depending on who the customers align to. So if we take a look in here, for example, we've got tools like BitTitan's user activation if migrating to Office 365 is a big option for you. We've got AppZero who do work around trying to abstract the software from the operating system to see if you can actually start moving some of those older things forward without relying on older versions of an OS. So you've got different options here from a variety of different vendors, and if any of these are things that you need to investigate, contact the vendors directly. You'll also see that some of the OEM vendors do have special offers around servers, etc. And even if these aren't the vendors that you're working with, even if you're building your own servers, for example, it's probably a good idea to think up some good solutions and some good bundles that you can promote to your customers to really help drive this Windows Server 2003 migration conversation as early as possible. With this scenario, Contoso are taking a look at how they can start migrating some of their older workloads or even some of the current workloads they've got up to Windows Server 2012 R2, but they're also starting to think about which are the workloads that might be better suited to running on purpose versus some of the ones that might be better run in the cloud. But also, how can they start looking at, maybe orchestrating a solution, so something that can help this migration from Hyper-V up to Azure. And what they need to do is make sure that the applications have been tested, that the migrations work, etc. So let's take a look at this. We'll jump into the Microsoft Migration Accelerator and some of the key features that it provides. So first of all, it works in a mixed network. So it migrates Windows physical machines, virtual machines. It runs with Amazon Web Services workloads and Azure. So really when it's going and trying to find what it is you've actually got, it doesn't really care where that information currently presides. Now, for you as a partner, one of the big benefits here is that you can go through and effectively kick off and monitor the customer migration and integration and recovery processes all from a single console. So even though customers may have a lot of control within that console, because you don't necessarily want to be involved in everything, this is something where you can still get a good overview of what's going on. Now, what we can also start doing with the Microsoft Migration Accelerator is perform guest level application discovery. So we can start ensuring that there's consistency across all of the virtual machines in a multi-tier application. So in this case, you may have virtual machines that have got dependencies on each other, and you don't want to move one from one network to another if it's going to have an impact on that application maybe not performing well or maybe not performing at all. So making sure that you can keep these different groups of applications together so that if you do decide to move, that it lets you know that you do need to move multiple virtual machines, not just the one. And then finally, it also starts providing cutover capabilities. So you can start doing things such as end-to-end recovery orchestration. So things like allowing it to switch onto an alternate network, making sure that it's being configured to work with the right endpoint, for example. These are all things that are part of this acceleration solution that Microsoft is delivering. So how do you start investigating this? Well, at the time of recording this in October 2014, this is still a preview program. So what you need to do is sign up via the Microsoft Azure homepage. You need to accept the terms and you fill out a short survey, and within a few days you should get a response back letting you know, hopefully, that you are in. Or even better, by the time this goes live, it might be something that is actually already available and you don't need to sign up for the preview. So what's required on your side? Well, you do need an Azure subscription. Now, the next one, and this is a critical one, is if you're saying, well, I don't think this is going to work for this particular customer because they don't have good bandwidth, well, that's kind of a blocker straight away with this one. This is something that does assume your customer has decent bandwidth. Now, decent bandwidth or good bandwidth or adequate bandwidth are all very flexible terms depending on what it is that you're looking to do. But in this case, we're looking to migrate potentially a lot of virtual machines or maybe a couple of virtual machines. So it's really up to you to sit down and go, is this something that's actually achievable for this customer? You also need to have something like a site-to-site VPN into Azure, or you need to have a NAT IP into Azure as well. And you need to go through and follow the sign-up instructions. So during the preview, because you get this special portal, it is a slightly different process to what you'd normally encounter when you do just jump in and start looking inside of Azure. Now, on the provisioning side, what you do is you have to set up 2 management VMs in the Azure subscription, and then you need to download software so that you can set up 1 management VM on-prem. But we'll talk about these in a bit more detail over the coming slides. So what are the different stages we've got? So let's jump in and start with discovery. So with discovery, it will take a look for virtual machines on your network, physical machines, machines that you may be running in Amazon Web Services, for example. It knows certain types of applications to look for. But now the important thing with this one is that it's for Windows 2008 and above. So you're thinking, well, hang on, what if I'm already running Server 2003? I thought this was about Server 2003 migration. Well, the issue is that Server 2003 is not something that this tool does support, unfortunately. So if there are particular workloads, for example, you'll need to address the migration of those onto a later version of Windows Server before you kick this process off. So this isn't a process that will go through and migrate the application to a new version of Windows as well as the same time as moving it up into the cloud. It's something that you do need to do as a 2-step process. Now, as you start taking a look at the protection side, You can configure protection from the source enterprise servers to Azure after installing the mobility service. Don't worry, we'll talk about the mobility service in the next slide. And as I mentioned, you can create a group for those individual applications as well. So if you know that you've got applications that have got dependencies on each other, so instead of thinking about it as a multi-tier database application, such as normally an N-tier application, even something like an Exchange server, you may not really want to move an Exchange server up into a hosted environment unless you're also moving a domain controller, because you want to make sure that there's high-speed communication between the Exchange server and the domain controller. So these are the types of things that can be configured in the protection area. Now, moving over to the cutover, you select the servers that you want recovered, and you can really use this as a disaster recovery tool as well as a migration tool. So you can choose the specific network settings, you can choose which switches that you want to take over when you do the cutover. So these are things where you can help to automate this process of switching from one network to another. And then specify the endpoints and the locations where you want them stored. So jumping into the actual components that are required here. So let's jump in. I've already mentioned a few of these, but let's drill into them in a little bit more detail. So first of all, we've got the mobility service. So this is a lightweight scout agent. You need to install that on each of the source servers in the organization. So think of this as the one that captures the data in real time. It enables the synchronization of selected volumes. It filters the rights made to protected volumes. It defines consistent bookmarks as well as consistency points for the process. Now we've also got the master target. So this is a dedicated virtual machine that's set up inside of Azure, and it acts as the replication master. So it's used for targeting the replication for the disks from the source enterprise. It also contains the retention data as well. So this is the change log, so you can use this to recover a virtual machine to a prior point in time or an application to a prior application consistency point. So this one master target can accommodate migration of up to 15 disks into Azure. So if you do need more than 15 disks, then you will need additional master targets in order to accommodate this for you. Next, we have the process server. This is something that you install in the enterprise, so inside your network, and this facilitates the communication between the mobility service on the internal servers and the master target on the Azure network. So don't worry, we've got a diagram coming up where some of these things will start making more sense. And with the process server, it provides caching, it provides queuing, it provides compression, encryption, and bandwidth management. So it's providing a few, background but very, very, very important roles. Now, we've also got the migration accelerator itself, but in this case, this is the portal. So this is that multi-tenant portal which allows you to discover the source enterprise and migrate your customers across to Azure. Now, the final piece of the process is the configuration server. So this is the one that's deployed inside of Azure. It provides the user interface, it gives the data from the master target, provides it to the migration accelerator, and regular synchronization occurs between the config server and the migration accelerator to make sure that you, as the person who's overseeing all of this, is getting the most up-to-date information. Now, as we jump in and take a look at the reference architecture, let's just start here with what's in Azure. So in this case, for you as a partner, you've got the multi-tenant portal or the MA, the migration accelerator, but then we've also got the master config and the target servers which are set up inside of Azure. Now, as we jump into the next piece and start filling in some more of the details, if we take a look at what's happening inside of Customer 1, you can see here that they've got VMware, they've got physical machines. So, even though, we live, in this case, I live in a Microsoft world where it wouldn't say VMware, it would say Hyper-V. We have to recognize that people out there are using VMware as well, and there's a lot of them. So we can go through and we can start taking a look at the compute, the storage, the networks, and then we have that process server which establishes the data channel out to Azure to start allowing some of this migration and reporting to occur. Now, similar thing when we take a look at Customer 2. We set up a data channel so this information can start being reported back through so we can see exactly what they've got, and then we can figure out what the next steps are. So for the outbound port configurations, what we can see here is that the configuration server uses just good old HTTPS, so it uses port 443. but the process server uses port 9443 and 9080. So what you need to do is make sure that that this is traffic that you are allowing out of the router in your customer organization, so these things can actually continue to proceed. So obviously this is something that if you're talking about smaller customers, this is potentially going to be overkill. But for some of your, the bigger customers in the SMB space who are looking at moving to Azure and the Azure Australian data centers, this is something that might start making a lot more sense as those 2003 and new workload scenarios start becoming more critical. So let's change gears a little bit here and start talking about some of the other Windows Server migration tools. So these are the tools that are included with Windows Server 2012 R2, and what they allow you to do is migrate certain roles from older versions of Windows up to newer versions of Windows. And what you can see here is that there's a mix of x86 and x64 servers from Server 2003 up to Server 2008 R2. And what we're doing here is effectively just grabbing the information that we need to move the roles between servers. So some of these roles, we'll talk about them in more detail in the next slide. But in this case, it's just a matter of, it might be configuring it so that we can migrate DHCP settings or DNS settings. But obviously there's a lot more, so it makes more sense to take a look at a more comprehensive list. Because as you can see here, it's fairly comprehensive in terms of being able to migrate the roles from old servers to new. So with these tools, these are Windows PowerShell tools. There is documentation included, and because we're working with Server 2012 R2 here, this is obviously the target OS. So what can we work with? Well, we can work with Active Directory certificate services, Active Directory Federation services. As I mentioned, things like DHCP services as well. Also, things like Hyper-V. So do we want to migrate Hyper-V settings? Do we want to migrate file and storage services, RDS, clustering, etc.? So with some of these things even in a smaller environment, you're thinking, well, would it be easier for me to migrate these manually? But what you can see here is that you can even migrate some of these from previous versions across to Windows Server 2012 R2 Essentials. So even smaller customers can benefit, and even things where if a customer is running Server 2012 R2 Essentials and wants to basically migrate those across to a standalone install of Windows Server 2012, that's also something that's a complete possibility here. Now, some of the support notes down at the bottom, you can migrate between physical and virtual. There's no real concern with that. And you can migrate from x86 and x64 up to Server 2012 R2. So even though more recent versions of Windows Server, so from 2008 R2, are all 64-bit only, that doesn't mean that it will only accept input from a previous version that was 64-bit. So your old 32-bit versions of Windows Server that we saw on the previous slide, they will also work. So when it comes to that assessment piece, so how do we actually assess or the discovery stage, discovering what's out on the network? One of the tools that Microsoft has made available to make this a lot easier for you is the Microsoft Assessment and Planning Toolkit. And what this tool does is it just uses standard Windows networking protocols to discover what's on your network and not just give you a spreadsheet or a database that's got all of this information inside of it. What it actually does as well is provides you with a list of reports that you can generate to give you indications of what workloads you're running that aren't highly utilized, which workloads are potentially good candidates to move to virtualization or to move to the cloud, for example. So if you haven't already taken a look at this tool, I definitely recommend that you just do a search on Microsoft Assessment and Planning Toolkit and download it. It's updated on quite a regular basis, so always make sure that you're working with the latest version. Oftentimes I'll also release a preview version, so I also suggest, if possible, sign up on Connect to get access to the preview version so you can play around and see what the direction is for the tool, and maybe even try that in a customer environment to see what additional information it exposes that previous versions didn't expose. Now, to wrap up this one, we've seen some of the different tools that are out there. We've discussed different tools. So MAP may be great for a smaller organization. The MMA solution might be great for one of your mid-sized customers. And then there are all the third-party tools available as well that will really help you target, very specific things. So if you've got a customer who's got a specific type of application or application set, you might find that there are vendors out there who do a fantastic job of, identifying the best way to move those forward. So up next, we'll talk about Active Directory, domain services improvements, and migration procedures. So come back and we'll start covering some of these off in the next module.